today we'll be discussing some topics of mathematics. Yeah, I can call it mathematics or either physics. So today we'll be focusing on calculus and then vectors. And I think you have a basic idea about what is there in calculus or what is there in vectors. You have studied all these things in detail in your schools. You are doing solving all these integrals or these differential equations. So we'll firstly focus on calculus. So how many of you have an idea about where calculus is being used in our life? So I think what is this calculus? It contains those differential equations and those integral part. So that is what we call as the differential calculus and the integral calculus. So where this calculus is being used in our daily life? Can anyone give me some examples in which field we are using this? Or are we using this? We have studied some formulas. We are using this. We are solving some problems, maybe double integral and all. We used to solve these problems. So in which areas we are using this? Okay. Someone has posted itself as engineering, in calculations, in mathematics, to find something which is really small. Okay. Architecture, yeah, that is completely fine. Architectural engineers, so those persons who use this idea of calculus, really, this calculus is really important for them. So it's not like we'll be solving or we'll be using this in the form of solving some differential or this integral equation. So it's like this calculus, either these integrals or differentials are around us maybe in one way or the other, and we are using this in our day-to-day life also. So I'll tell you why this differentials or this integrals is this much important. So it's like they are having those ability to model and also control the systems. So that is giving us some power or some idea to use this calculus in our daily life. And the basic idea was, it was the first time this calculus was initially developed for this navigation purposes. Now also it is being used in that area, but actually this was being used for this navigation purposes. So we'll see, I'm sorry. So we'll see the idea of calculus in detail. And we'll be discussing about what is the definition, where it is being used in real life, about the branches which are using this idea of calculus and some of the applications. So what is the definition of calculus? So it's like maybe you have studied something like integrals or differentials, but the definition actually is calculus is referred to as infinitesimal calculus or the calculus or infinitesimal. So it will be actually a new word to you. It's infinitesimal. The meaning of the word is that maybe some numbers or which are the quantities that have value which is very close to zero, but it is not exactly zero. So someone has mentioned in the chat box, like we are using this calculus to do something with the very small values or pretty small values. So calculus is defined as, or it can be referred as something which is referred to as the infinitesimal, which means those quantities which have values which are very low or which are something above zero. It's not exactly zero, something above zero. So this is the actual definition of calculus. It's a branch of mathematics that studies continuously changing quantities. So the idea behind the calculus is that we'll have some, we used to do this graphical and all those problems. So we can see that in the graph, the value will be changing continuously. So it's the branch of mathematics which studies or which helps us to study something that is continuously changing. And we can call the two branches of calculus as differential and the integral calculus. So it's a combined mathematics of the differential as well as the integral calculus. So you know that we have this geometry where we study something related to this shapes. In algebra, we study something related to the arithmetic operations. Similarly, calculus is a branch, or we can call this some method or something where we use to analyze or where we use to calculate something which is related to maybe limits or maybe differentiation or maybe integrals of functions. with one variable, or we are doing it with more than one variable. I'm sure that you have done problems with more than one variables also. So you have a graph with you, right? I have shown a graph with you, and it's like somewhat an uneven graph. And I have marked one point like steepness and another one is area. So why calculus is, let me ask you two questions. How we are going to find out how steep is a function at a particular point? How steep is a function at a particular point? And the second question is, how am I going to calculate the area underneath the graph at some point? So maybe most of you have answers with you. How we are going to calculate the steepness? We use the derivatives for this purposes, or we use the differentials for this purposes. So how steep is a function at a point can be calculated by what we have with us, that is the differential calculus. And the area under a particular graph or something, or area under a particular point, which is somewhat irregular, we use the differentials, we use the integrals for calculating this area. So this is what is basic called the calculus, or this is what is the basic idea behind calculus. So we have integrals to calculate something and we have differentials to calculate something. So we'll see this in really detail. Okay. So what is derivative? So this is the definition, or this may be the part you have studied in your school. So it's like the rate of change of a function. We can call this as derivatives. Or you'll call this derivatives as derivative measures the rate of change of function at a particular point. So the differential of a function, which is actually measuring the rate of change of a function, or it gives us some explanation in such a way that, or it gives us an idea about a function at a specific point. Now we'll move on to the integrals. So the integrals is the measure of the area under a curve, maybe of a function, or it's like it accumulates some of the discrete values of a function over a range of values. So you have studied these integrals with a range of values and all. So this is what is the basic definition of integrals or derivatives. So now these integral calculus or differential calculus is what is defined in the fundamental theorem of calculus. So I have given the two diagrams here separately for those graphs, that is derivative and the integrals. So I have given these diagrams of the two separately. Now read the definitions here. So first we'll look into what is derivative. So what is the derivative, or what is there in the differential calculus? So differential calculus cuts something into small pieces to find out how it changes. So this should be the basic mathematics which has to be taught to you. That is, in differential calculus, we'll cut something into small pieces and we'll find out how it changes. So you can see the graph here, right? Yeah, this is the one. So here I need to find this at a particular point, right? It is a measure of rate of change of a function, and we have to find this at a particular point. I need to find the steepness of this function at that particular point. So what I'll actually do to solve this, I'll take some other point in the graph and I'll calculate the distance between them. The next thing I'll do it, I'll take some other point and I'll calculate the distance between these two. Then I'll come closer and I'll find the distance between these two. So I have multiple values. I have solved multiple values or multiple distances. So comparing all those values, I can find out that they'll somehow come to a particular point, or they'll somehow merge to a particular value. So this is what is the basic principle behind the concept of differential calculus. It is going to cut something into small pieces and it is going to identify how they are changing. And the next is also with the concept called the integrals. So the integral calculus integrates or joins the small pieces together to find how much there is. So in this graph, we have shaded this portion. So what we'll be doing, we'll be cutting this into separate sections, maybe some rectangles type of sections. And then we'll be working out on each function. So we can call them as opposite of each other. So it's like here, these small pieces are together and we'll find out one function, and here we have something which is cut into small pieces, and we are going to find out how this is changing. So this is the basic idea between what is called the differential calculus or what is called the integral calculus. So now, so that's all about the basic definition or the basic concept about what is calculus, what is integral calculus, and what is differential calculus. So now we'll move on to the where this is being used in our life, maybe in our day-to-day life, or whether it's being used in some of the used by some of the engineering professions, or are there any other areas which is using this concept of integrals or differentials? So I'll tell you, this concept of calculus plays a very important role in our daily life. You can see a diagram here, right? This is something, a shell type of something. So this, we can call this as a classical image to depict the growth and change which is related to calculus. It's like, we can't say, looking into this diagram, which shape is this? It's not like a fixed shape, like maybe square, rectangle, or circle or something. It is what in this diagram is, it's constantly changing. So at one point we have some shape like this, at another point we have some shape like this. So it's constantly changing. So this is a perfect example of something which is in the nature. So this is like, we'll not be able to calculate, or we'll not be able to analyze this easily. So here we need to make use of the concept that is what is called the calculus. The Nautilus shell is a classical image used to depict the growth and the change related to the calculus. So this growth and the change can be studied by the integral calculus or the differential calculus. So now we'll see the different areas. So I have mentioned some of the areas where this is being used. So in this graphs and all, we are using the concept called the calculus to solve the areas of some complicated shapes, maybe in some surveys and all for the evaluation purposes. In vehicles, we are using this calculus. That too, most probably in the safety aspect. Then in business planning, credit card payment records, all these are some areas where the concept of calculus is being used. Either it's integral or differential. And it is being even used by the biologists or economists, architects, medical experts, maybe engineers, statisticians. All these people are using the concept of calculus in their day-to-day life, or in their experiments, or in their research areas. So now I'll quickly mention some of the subjects where we have studied or where we are applying this calculus. It's not like in mathematics, I have one problem, it is asking me maybe integral of something, or maybe differential d by dx of something. It's not like that. They are having something to do in all these areas or in all the topics we have studied. Like it is having applications, or it is being used in chemistry, maybe physics, biology, finance, or even used by the economist. So in physics, maybe in most of the concepts, physics is having a lot of concepts, right? So in some of the concepts, we are using this concept called the calculus. So I have given some of the examples here. So to calculate the velocity of the trajectory of an object, maybe in considering the positions of the planets, we have seen what is electromagnetism. So it is there in the concept called the electromagnetism, being used in the areas like motion, electricity, heat, light, harmonics, or acoustics, astronomy, dynamics. Maybe there will be some new terms to all of you, but it's like you should, if you are not familiar with those terms, maybe you can ask me at the end of the session, or maybe you can Google it yourself. Then advanced physics concepts like electromagnetism, Einstein's theory of relativity, everything uses calculus. We know that maths and physics are really integrated with each other. And physics makes use of this calculus really in a very good way, or physics is using mathematics or this differential calculus really, really important in the calculations of physics. Then for the chemistry. And I'll tell you, more than differentials, physics is making use of the integral calculus. In physics, we mostly use this integral calculus. Differential calculus is also there, but we mostly concentrate on the integration part. So the next is chemistry. So in chemistry, we use the calculus to determine the rate of a chemical reaction. Here also we are using this integration concept. It's like how fast a reaction will take place, or what is the time. So we use the calculus to find out the rate of the reaction, and also calculus can be used to predict some of the functions, like what time it will take for this radioactive decay. And we can tell like for the rates like birth rate, maybe death rate. So all these areas, the chemists are also using the concept called the calculus. Now the next subject is biology. So here, it's like every biologist, they have to study the interaction of different species with the ecosystem. So I'll tell you, you have studied about maybe in your 10th and all, you know the concept of predators and the prey. So how this population is changing, how their graph is changing, how is that ratio predators to prey. So we have to find out all these things, and they make use of the concept called the differential equation in analyzing what is happening. So they have some real life situations, or they have some situations in which they have to make the analysis. So for making the analysis, they are making use of this calculus. Then I'll give you one more example. It's like in bacteria culture and all, this is being done by most of the biologists. So during that time and all, they have to identify how much the bacteria will go in this particular criteria. Were they are given this much light, or were they are given this much supply, where the temperature is this much. So whether at this temperature they'll die, or whether it has to be cold. So there are different criteria that they need to analyze. So in order to determine the exact growth rate or exact rate of the growth of a particular bacteria, that is mostly in this bacterial culture and all those things, they are relying on this integral of the differential functions. So even it's like biology people are using something called the differentials or the integrals. Then there are some more aspects, like how the skull will look like, or how the backbone will look like, right? It's not actually something good structured or something. It will have maybe different projections and all those things. So to calculate this or to measure this also, we need the help of calculus. Then in most of the experiment, they used to calculate how much drug is there in a particular living organism's body. So in order to find out the concentration of drug in a particular person's body, maybe a person or something, so in a particular person's body, it can be also answered by using this calculus, or they are relying on calculus to find out all these calculations or criteria which are essential for them in their working profile or maybe in their field. Now is the financial sector. So here also there will be a lot of data or lot of evaluations, or maybe lots of surveys need to be done. So in all these surveys, maybe to analyze these graphs, or maybe to come up with tricks on how to develop or how to start something new. So in all these things, or how to choose the stocks, how to analyze stocks that are already there. In all these areas, they have to use what is called the calculus. So it's mainly like they have to have an analysis by making use of what is we have studied in our school, that is the integral and the differential calculus. And in some cases for the prediction also. So it's like we are going to perform a survey. We have different questions and we are going to give this to different people. So we can predict what will be the output of the survey, maybe before going for the survey and all. So calculus is allowing those persons to make a more accurate prediction in the regard. Then after finance, I'll give you some examples also. This is being used by some credit card companies also. It's like so many banks will have their minimum limit or maximum limit payment. And maybe in credit card system, we have that payment date, or maybe in the time of the statement generation. In all these areas, we need calculus to make some of the evaluation or to make some of the analysis. So now the next part is economist. I don't know how much you will be able to understand all these terms, which includes this finance or this economic type of terms. So if you have any difficulty, you can ask me at the end of the session, or you can even message me, or you can Google yourself. Okay. So everyone will have an idea about this supply, demand, and all those things. So here also the economists are using this for the prediction purposes. So to predict the supply or the demand, or what will be the profit, and maybe to determine the price elasticity of a demand. It's like maybe every company, or they'll have an elasticity curve. So it's like they need to measure this elasticity at a particular point, maybe on either supply or demand curve. So they'll have a supply or demand curve, and it's like a simple graph itself. So in that, they need to calculate an exact point. So we have studied, so that steepness, we have the differential calculus to calculate this. And maybe there will be small changes in the price, that too very low changes in the price, which can also affect their industry. So they have to calculate, or they have to take all these things into criteria once they are performing the calculation. And it's like to calculate the exact measure of elasticity, maybe marginal cost or marginal revenue calculations also, an economist needs this area. Then all those people who are doing this research, so all the researchers has to rely on calculus, because they'll be researching to find out something new, or maybe find out something after their research. So they have to perform some calculations, or they have to perform some analysis, they have to make some comparison. So how they can improve, how they can raise all the things, or how the profit can be improved, how production can be improved, all these things can be researched through the area called the calculus. Then for the graphics artist, maybe in three-dimensional modeling, or all those areas, maybe in movies, video games, everywhere they are using the calculus. So I think I have given you some idea about where we are using this in our real life, or maybe where you have seen these things. So now I'll give you some areas where the engineers are using calculus. We know architectural engineers, right? It's being mostly used by the category of engineers called the architectural engineers. Even other branches are using this, but mostly the architectural engineers are concentrating or focusing on this. So this is being used in different infrastructures. So I'll tell you, while I'm going to construct a bridge, or I'm an architectural engineer, I'm going to design a bridge, I need to consider lots of factors. So there will be at this, which distance I need to construct the bridge. So what are the environmental factors I need to consider? What is the weight? So there will be different factors. So the differential or the integral calculus will be helping these architects to create a robust design, or to create a good plan. So maybe in any designing area, this calculus plays a very important role. So it's like earlier we used to have this shapes with or these buildings with perfect symmetry. So to create those buildings with maybe it's which are non-symmetric, you know what is symmetry, right? So these arches and all these things we know. So everything was constructed up to one point with this perfect symmetry, or following that perfect symmetry. So it'll make some beautiful buildings. So now there are constructions which are not symmetric. So the calculus is playing a very important role in all these things. So to create some odd shapes, so which are not like which are not perfect in their shape, but they are beautiful, or they are good to see. So in all these things, calculus is making use. So they are constructing their plans based on this calculus, because they have to have many calculations based on what will be the load, or what will be the distance, or what will be the strength. Are there any environmental factors which are affecting this? So they have to have some criteria in themselves, and they have to make an analysis. So for this part, calculus plays a very important role. Now the next is aerospace engineers. So here I'm going to refer some terms which are actually being used by these engineers. So it's like there's an ideal rocket equation. So in ideal rocket equation, it's the basic equation every aerospace engineer studies. So the ideal rocket equation, which makes use of the principle called the calculus. So it's like thrust hour time, which is calculated by using this equation, is an application of calculus. Maybe in rocket launching and all, they have to make some analysis, right? So while launching a rocket. So there also we need the calculus. What will be the gravitational force? What will be the speed? So different things. At what time? How much time will it take? So by what time it will reach space? So there are different criteria which needs to be analyzed. So to deal with the complex systems, this calculus has a very important role, or in complex systems, this calculus plays a very important role in solving all the complex systems, or the complex calculations, or solving the complex figures. So the next is for the space flight engineers. So for the long space missions and all, when planning these long space missions, calculus has some part to do. So while we are going to launch something, so it's like the different velocities will be there, that of the planet or that of the earth. So where we are going, or whether it's space. So to launch such a thing, they must consider the different velocities, maybe of the Earth, of the planet, or where it is targeted for. Then what will be the gravitational influences, whether there will be any influences from any other maybe planets or any other objects. So lot of things has to be considered. So this is being used even by the space flight engineers. So now the electrical engineers. So they are also using the concept of calculus. So the integration can be used to calculate, or it is used to determine the exact length of the power cable which is needed to connect two substations. So I'm having two substations and I'm going to connect both of them, and which are maybe miles apart. So it makes use of the concept called the integration to do this. So I'll tell you, most of the electrical engineers, they highly rely on the concept of the physics for their working. So maybe either electronics or electrical or maybe control system engineers. So this is a field where they mainly rely on the principles of physics. So they'll be able to, or they'll have situations where they have to calculate the area, length, or volume, or maybe some other parameters also. So I have given here 2 to 3 things, or 2 to 3 names where this is being mostly used by the electrical engineers. So it's in the vector manipulation, maybe electrical machine design, or electrical energy transmission, maybe in control systems. All these are areas where we are using this calculus. So now the next part is structural engineering. It's also a part of maybe a combination of the civil. So civil engineers, all the civil engineers will study some part called the structural engineering. So it's like a basic idea is to determine the forces of the different structural elements. So it's like how the strength will be, what will be the capacity, what will be the soil texture, or what will be the pressure. So all these things need to be considered by the structural engineers. So what will be the bearing capacity, what will be the shear strength. So all these are different terms which are in that particular branch. Okay, so it may be new to you. So in all these areas, we are using the what we call as calculus. So now moving on to the next part, that is a mechanical engineer. So in everywhere, it's not like calculus is not in any profession of engineering. So you'll all study, all the mechanical engineers in your maybe third or fourth semester, you'll study the HVAC design. So it's the Newton's law of cooling. It's a part of differential equation, or it requires some integration to solve this part. Then in the case of frictional forces, maybe in the case of designing a pump by these engineers, or to calculate the flow, or to control the flow, or calculating the amount of power. So all these areas they need to do some mathematical things which is related to what we call the calculus, that is the integration and the differentiation. Then if this is being used by aerospace, civil or aerospace or structural engineers, it will be obviously used by what we call the category civil engineers. So they have this area called the fluid mechanics. So they'll do this integration and differentiation. They'll solve most of the problems related to this integration and differentiation. And some of the hydraulic analysis, maybe in designing of some of the channels, everywhere they uses this calculus. So mostly in two areas, like first one is basic fluid mechanics and second one is hydrology. So where they're going to create something, maybe a curve or maybe a plot of something where they need to calculate some volume, or maybe they'll be able to calculate some area under the curve or something. So obviously we need integrals or differential to do this, because that's the only way to perform this calculation. So now I'll give you some other applications. So till now we have or discussed something related to the different branches of engineering. So now we'll look on to some models. So the first one is weather models. The second one is improving public health, or which is called as the epidemiology. And this is being used in different search engines. So we can see everything in detail. So the first one here is what is called as the epidemiology. So it's a particular science. We all know, like we are in the current situation where we have all this COVID-19, all these situations, all these risks and all. So this is a branch of science which includes the determination of rates, that is quantification of disease occurrence within a specific population. So now we are making use of this particular thing called the epidemiology. So it's like we need to calculate what will be the growth, or how much will be the spread. So what will happen? So this is being done by what we call the epidemiology. So the field of epidemiology can be called as the study of spread of infectious disease, which heavily relies on what we call the concept of calculus. So here also we'll have this graph. So mostly if we are searching on the COVID-19 spread and all those things in the internet, we'll have some graphs for the analysis. So we'll be able to understand what is there in the graph by looking at it, right? So this will heavy, or this is really based on the concept what we call the calculus. So I'll give you some analysis based on this. So the first one is, in the case of COVID-19 and all, we'll categorize the people into three parts. So the first one is people who are susceptible to the disease. The second one is already those people who are infected and people who have already recovered. So we need to have an analysis about different category or different parts of the people. And for this analysis, calculus helps us. This calculus will be helpful, or it will help us in determining how far or fast the disease will spread. Or it will help us to identify whether it's a threat, or how we can treat it, or how much time it will take for the graph to go down. So all these factors can be calculated with the help of calculus only. So now the next part is, so here I have given some terms where the calculus is really important in the field of epidemiology. So it's like the rate of infection and the recovery rate changes over time. We know, right? In day-to-day basis, we are seeing in our newspaper the rates are changing. It's like if today there are 2,75,000 people, maybe tomorrow there are 3,00,000 people, and the positivity rate is maybe 20%, 25%. It is also continuously varying. So the thing is that in all these areas, we know the equations must be dynamic enough to be responsive, which means we need new models will be coming every day. So we need to have an analysis every day or maybe every time. So we are making use of the concept of calculus for making this analysis. So the next part is weather models. So we know that this field of weather prediction and all is improved a lot now. So it is only due to the technological improvements. So the computer modeling and all, which is being heavily relied by this weather predictors or those persons who work in this field. So they are using this calculus to predict the conditions or what will be the weather. It's everything which is based on some probability or maybe some analysis or maybe some graphs. So in all these areas, calculus will be there. And in the case of weather forecasting, mostly they rely on this technology or maybe some of the programs which are being developed by this computer science engineers. So it's like they'll consider some factors, like what is the moisture level, what will be the temperature, what is the wind speed, so whether it will rain or whether it's going to be hot or whether it will flood, or all these conditions they'll predict only on the basis of analysis of some of the factors. So where we need the calculus. So I'll tell you, there are persons who are called as a meteorologists, right? So the basics is mainly they are focusing on the differential equations. I'll give you some example. It's like we have to have an analysis of how the temperature is changing, how the pressure is changing, what is the temperature in the atmosphere at this current time. So it's like all these things need to be calculated, and this need to be calculated, or this will change drastically. Maybe it will change in every 1 hour or 2 hours, maybe in half an hour or something. So we need to have a continuous analysis of all these things. Then only we'll be able to predict this weather. So the next part is this is being used by the search engines. So I think everyone will have an idea about what is the basic or what is in the background of search engines. So it's completely run based on the algorithms. So different companies or different search engines use different algorithms. So if a person is typing something, so it's like these algorithms are making it work out. So these algorithms maybe have to search and they have to predict these answers really quickly. So in these areas and all, we have a lot of data and they have to search in that data, they have to make an analysis and they have to give us the reply. So these algorithms are that part which makes these search engines work this much quickly, and they have something that is in the calculus. Then to find out these locations and all those things also, we need some part of calculus. So here, it's like everything, every application we have studied or every application we are seeing will not use the calculus or the differentials or the integrals in the same way. It's like they'll have some certain set of constraints or rules. What this calculus or this integrals, we know right limit or something. So we'll have some set of constraints or some set of rules. So what they'll do is they'll work within that conditions and they'll produce us, or they'll come up with the most possible or the most logical result or most effective result. Then I'll give you some more examples which you'll be able to understand easily. So the first one is shipbuilding. So you can see in the diagram like a hull. I have marked it here. So this curvature of the hull. So it's like which is being calculated by the differential calculus. Then area under the hull. So area we know it's being calculated by the integrals. So this is simply being used in the area called the shipbuilding, where we need to have this differential as well as the integral calculus to compute or to calculate two things. Then it is being used in the construction of dams also. So maybe we need to find out the force in which the water will flow, or how we have to design these dams. And also in these area also, calculus plays an important role. So now the next part is vehicle safety. So I'll give you some idea. Calculus is used to improve the safety of vehicles. So I'll give you, if you are driving and we feel like some accident might happen. So the first step every driver will do is what? They'll brake it, right? So here, in order to calculate this braking function, we are using the integration. So all this automotive or the mechanical engineers are using this integration to use to analyze the crash test data, and which is used to improve the safety of the cars. They used to conduct these tests in their maybe test labs or testing centers and all. So it's like they'll have some dummy in the car, maybe with seatbelt they are seated, and they'll recreate this accidental situation and all. So it's like how much they are pressing brake and how much the vehicle has to stop. So it is being calculated by an integral function. So they'll experiment on different values and then they'll come to a conclusion and then they'll implement it in the vehicle they are going to launch, or in these vehicles we are using. So all these are different areas. Even now these engineers are calculating this, how this is working. So everywhere there is something related to mathematics, right? So they are using this simple integrals or differentials to calculate this or to make an analysis. So in that way, we'll be safely traveling in our cars. So in this car braking mechanism, this plays a very important role. So I think that's all for the part of calculus. So you have received some idea about the different fields where we are using this in our day-to-day life, or maybe in some other areas also, maybe around us. Even this weather prediction, or even in the search engines we are using, or even to get the statistics of these, maybe COVID-19, all we are using this. So now we'll move on to the next part, that is what we call the vectors. I know you have a basic idea about what is vectors. We'll be using this concept both in mathematics and the physics. So I'll give you some example. So you are sitting in a table. So you have a cup of coffee in the table and you have your eyes closed. So the only information given to you is that maybe the cup is located at maybe 1 amp distance from you. So what you will do? Will you be able to lift it? Not at the first attempt, because your eyes are closed and you know there is a table and it's at 1 amp distance. But you don't know whether it's located in the left or the right or maybe in the center. So you don't have an idea about the direction. So in the first case, it will take you many tries, right? So you'll check for the left to lift the cup, whether the cup is in the left, you'll go for the middle, then you go for the right. So if you're not able to pick it, yeah, it's because you don't know what is the direction. So in the next case, if you are informed that it lies in front of you, so you'll easily locate it or you'll easily pick it because you know it's 1 amp distance and it's in front of you. So here it means the direction is it's in front of you and the magnitude is it's 1 amp distance. So this is the way we are using vectors in our day-to-day life unknowingly. So it's just a simple situation I have told you where we are using vectors in our daily life. I'm going to pick something. I need to know the distance and I need to know the direction. Then only I'll be able to pick it, right? So I'll give you some common examples also which everyone used to do. So it's like we used to have our umbrellas in the rain, the direction, right? So all these areas we are using, or unknowingly we are using vectors in different places, including this in our real life. Now we'll move on to the definition part of vectors. So they can be called as the mathematical elements, which can be used to represent an entity which has both magnitude and direction. Now we know, right? When we have an idea about the vector, the magnitude and the direction, I was able to pick the cup of coffee at the first attempt, or maybe tea at the first attempt. So it's like vectors denotes the mathematical or the geometrical representation of such a quantity. And we know that examples of so many quantities we have studied in our classes. It's like velocity, force, or acceleration, weight, or momentum. I know most of you have solved so many problems with all these concepts. So some of the applications of vectors, it's like we are unknowingly using this in different areas. So this is being used in games, this is being used by the being used in different military sectors, or maybe in the roller coaster games, maybe in different sports fields or crosswind. All these are some of the areas where these vectors are there. So simply we have a game. So in these games, the vectors used to store the position and direction and the velocity. So they'll store these three information. So we need to know the position, and we need to know the velocity, and we need to know the direction. Then only this will work out. So here the position vector means how far the object is. So the velocity vector means how much force we should give it, or maybe you can call it in time regard also. So how much time it will take to reach that destination. And the next one is direction. So indicates the direction. So these are all the fields where we are using these vectors, but we are not thinking about it. So the next one is canon. So you have seen this maybe in some of your games, maybe in some of the videos and all, maybe in films. So this is a part of maybe a device which is being used by the military. So here also it's carried. How much should be the rate of fire? In which angle they should fire? So what will be the range? What will be the mobility? What will be the fire? How much they have to fire? In which direction they have to fire? So this is being used in the battlefield according to the situations. So this simply works based on the principle of vector. So this is a very simple example, and this completely works on the principle of vectors. There are many fighter planes and all, they use this auto cannons. It's just the simple cannon being used by the military. There are auto cannons also which are being developed. So this is being used by the different fighter planes and all. We use this. So now the next part is roller coaster. So in roller coaster also we are using this concept of vectors for its working. So I think like most of you have been in this ride maybe once or twice. So it's like this motion and this roller coaster is response to Earth's gravitational pull. So I'll tell you how we are going to work out, or what is the principle behind this roller coaster. So it's like motion and this ride is responsive, or is the response to the Earth's gravitational pull. So here we have to initiate the movement. So what we'll do is we'll have a motorized chain, or we'll have a chain. So we'll pull it, and this will cover the first big hill. So it's like they'll go to different rounds. Like, so the first one will be the highest, and so that's why we are calling it as it will move to the top of the first big hill. So once it goes, it'll automatically go higher and higher. So once it goes high, its potential energy will grow and it will reach to a maximum range. So that is the first step in which it is working. So once the potential energy reaches to the maximum, so this energy that will help it to fall down. And there is also some influence due to the gravity. So it will fall down in the same way, and it will stop. So this is what is there in the roller coaster. So in these roller coasters working also, we need what we call the vectors for this direction and for its movement. Then we have the sports games. You know, in each and every game how this is going to work out. So the first one is cricket. So it's like I am a batsman, I'm going to hit a ball. So if I'm going to hit a shot, how it will be? Maybe it will be 6, maybe there will be catch, or maybe it will be 4. So there are different possibilities. So it will depend on what? in what angle the batsman has put his shot, or Batman has given his shots, then at what velocity he's hitting the ball, and how much speed was there when the ball was coming. So all these things. So you can see in all these areas we have this angle. So in these case we know this two parts, right? So we have two incidents in the case of this cricket. So then it's all about vectors, and we can find the next. This is also being used by this football match. I mean, football players and all. Maybe they have to have an idea about the direction or the trajectory of the ball. In different games, like maybe basketball, golf, billiards, maybe snookers. In all these games, the concept of vectors are being used by us. We used to play all these games, but we'll never think of the concept of physics or mathematics in it. So now the next is the crosswind, or the concept of crosswind. So I'll tell you what is crosswind, or what the concept is. So crosswind, we can call it as a particular wind component, or a particular category of wind which has a perpendicular component to the line or the direction of travel. So this is one thing which happens to these flights when they're trying to land. So when a plane comes to land, there may be some difficulties of this crosswind. So what the pilot will do is he has to find out the resultant velocity and the direction, and he is using vector also. So it's like I'll tell you, those traffic controller who is instructing this pilots, they'll tell like, you have to be careful with the vectors. Expect this vectors for while you're approaching. So all these communications will be there. So this is also a case where these vectors are being used, and they have to be careful. So they use to calculate these vectors to avoid this concept called the crosswind. So now these vectors are being used in chemistry. So I think you have studied about this bond polarity and all. So vectors are used to calculate the bond polarity. So there are chemical bonds with one slightly negatively charged and the other one is positively charged. So there will be an electric field between the positive and negative. So all this needs to be used in the calculations which is being done in the field of chemistry. So now we have the field called the computer science, where we are mostly using the concept of the vectors. So we use this in data representation, maybe in model representation, maybe in learning and training and statistical machine learning. So I'll give you some idea about all these terms. And I think most of you have an idea about what is array, what is called as array. So we call array as a data type, right? And what array means is it is going to store data in a particular manner, maybe in an organized manner or in an arranged manner. So in the mathematical way, we'll call these vectors as arrays. So these vectors are being used in the fields called the artificial intelligence and machine learning and all. So the first one here represented as data representation. So we can use these vectors to represent the data. Maybe it's like either representing an image or maybe some bits, we can use this concept of vectors. So the second one is model representation. Maybe in some artificial intelligence model or maybe in some machine learning models, these vectors are used to store these representations. It's like some of the internal representations. These vectors are being used, maybe for storing some predictions data, or maybe for storing some large amount of data. From that, this programmer has to make some predictions and all. And the next part is learning and training. So I could tell you for the designing of algorithms or to have a dimensional analysis and all, this vector plays an important role. Then it's also used in the statistical machine learning. These are some of the fields where the computer science engineers use vectors. Then it is being used in the image processing. So it's like the vector concept is being used in image. You can see that a screen or a particular image we are viewing is it can be, we can rearrange it as a maybe a matrix and we'll have some pixels of data in it, right? So the pixels will carry some vector of information, maybe like either brightness or color, whether the red component or the green component or the blue component, or what information, maybe the color components or maybe the length or maybe the gradient, or what will be the gray level intensity or what will be the color intensity. So all these are some of the components. And here they can make use of the feature extraction. So this feature extraction also makes use of the vectors. It's like each feature will be represented by each vector. So I'll tell you some example. It's like what will be the shape, how much will be the region. So all these things can be represented by vectors. So this is being used in the area called as the image processing also. So now the next important areas, this is being used by data science programmer and also programmers. So all those people who are interested in data science and programming concepts, they are also using this concept called the vector. So what the data science means is it is a process of finding maybe hidden patterns from unprocessed data. So it's like we'll have a lot of data and we'll have to find out some of the hidden patterns from the data. So here all these data points or this raw data are being represented as vectors. So in the case of data science and programming, we are not concentrating that much on the direction. So it's like we can go for this 1D or 2D and all those things. And in the case of programming languages, these vectors are used for storing these data elements, maybe of same data type or maybe of different data type. So vectors are used in different fields in different ways. Then this is also being used in the wave propagation. I know you have an idea about the wave propagation uses of vectors. So either it's longitudinal or transverse wave, we are using this vectors. So what do you mean by this wave vector? So it's like something which helps us to describe the wave or its conditions. So what will be the magnitude or what will be its direction? So it's like what is the wave number, whether it's inversely proportional to wavelength or what will be the direction of the wave, how the propagation is happening. So all these things can be a part of vectors. Then it's like I'll give you a one-dimensional wave equation. I think most of you have encountered this equation. It's like phi of xt is equal to a cos of kx minus omega t plus phi. So we have different values, right? So we can use some of these mathematical equations to solve these vectors, where we will make use of the concept of calculus that we have already mentioned. Then in the quantum mechanics also, we are using this concept of vectors. So I'll give you some example. So we have seen this quantum computing, right? So what is quantum mechanics is? It's the science that is dealing with the behavior of the matter and light on an atomic or subatomic scale. So it's somewhat similar to this quantum computing. So it's the science that deals with the, based on this quantum mechanics, the quantum computing is working. So it's the science that deals with the behavior of matter and light on atomic or subatomic scale. So here, based on the properties of different atoms or molecules, we'll be using this different equations. And in that field also, we need these vectors for representing them. So vectors are used in the representation of all these. And I'll give you an example, like most of the operations which are occurring in this quantum mechanics or computing are linear equations or linear operators. So most of them will be represented by matrices or maybe as vectors. So it's like the quantum mechanical operations or the operators, we'll represent this as matrices or as wave functions as vectors. So here also we have this vector space or this vector operators being used. So I think that's the end of the session. There was some terms which was difficult for you to understand. I know that. But I think it will be helpful for you to some extent. I have taken some examples from the daily life and I have concentrated more on that. I think it has helped you to someone. I'm actually sorry, there was so many charts in the chat box. Okay, it's like maybe accidentally the chat has seen to everyone. Okay. Now it's changed to host and panelist. Okay, so I think like some of you have received some ideas of some areas where this vector and calculus is being used, and that's fine, I think. So if you have any doubts, I have used many of the terms which are being used in the different areas of computer science or maybe mathematics or even by structural engineers. But we all will study some stages of engineering. So you all will have some common topics in your first year. Maybe most of you will be studying that same thing in the first year. Maybe you will study some mechanical or mechanics. In my time and all, while I was studying BTech, I used to have these common subjects. So I used to do this mechanical labs. I used to do this smithy fitting or electrical labs and all. So it's like you will study a basic of all the subjects. So you should have an idea about these things. Even some structural or even some architectural or even some civil drawings itself, you have to study. So I think somehow this has helped you. So I have given the number. So if there is anything, you can mail me or you can contact me. And I hope this has helped you.